In this section, we will explore the impact of initial inventory on our ordering decision, and then also we will look at the issue of multiple order opportunities. So, in a case where the manufacturer has initial inventory, that initial inventory can be used to offset the demand. And if you use it to offset the demand, then you may have a situation where it's not necessary to actually produce anything more. So you have a trade-off between using the on-hand inventory to meet the demand and avoid paying that fixed production charge. What's really driving this is that fixed production charge. For you to be able to do that, you must have enough stock, sufficient stock that essentially the profit that you're getting is more than if you would actually have to produce at all. All right. And then the other opportunity is what you're trading that off against is really paying fixed charge if you do decide to produce. So you got to make sure that if you're going to incur that fixed charge, that your profit in the end, your expected profit, will be greater than if you simply just use the initial inventory that you have. So here is a line that represents if we had, if we were not going to incur that fixed cost at all, but then if we are going to incur that fixed cost, then we have to reduce our total revenues or our total profit by that amount, that fixed cost. So the second line, the dotted line, represents the cost if we actually do produce and have to incur a fixed charge. So at what point should you decide whether or not you're going to produce? The way to do that is to really find the optimum point if we're actually going to produce, which is ready to produce 12,000 units. That's the optimum. That's where we can maximize our profit. But if you were to take that and draw a straight line across there, well, it turns out that that profit level sort of is equivalent to having 8,500 units of initial inventory. Now I'm showing 8,000, but that's because I'm not drawing this properly. But if I were to come down, it's probably somewhere around here. It lines up with 8,500 units. So if you have 8,500 units of initial inventory, all right, then don't bother produce, because the best you can do if you do produce is the profit level associated with 12,000. And since those two are equal, there's no need to produce. Now, if you have more than 8,500 units of inventory, it still does not make sense to produce, of course, because as we already said, you've already reached the maximum. But if you have less than 8,500 units, you should really consider going ahead and producing, because then you could bring your total profit level up to whatever that amount was, when the maximum amount that you'll get when you produce 12,000 units. So we'll kind of produce up to 12,000 units. Okay, and it can be demonstrated, and here's an example that actually shows that. If you had initial 5,000 units, then and you didn't produce anything, your profit would be $625,000. But if you then decided that you're actually going to produce up to 12,000 units, you could see your profit rising to $771,000. All right. So essentially, the difference is caused by the additional production between 5,000 and 12,000. Okay, but that has, you have to recoup, or you have to take away from that the fixed charge plus the cost associated with producing that extra 7,000 units. And that could all be computed. But what if your initial inventory was 10,000? Does it make sense? And the analysis here shows that you will not get any additional profit from producing the extra 2,000 units. So you find that as a result of this, you have a rule that says if the initial inventory is 8,500 or less, go ahead and produce. But if it is more than 8,500, do not produce. Okay, and that's called an SS policy or min-max policy. kind of an idea. The maximum that you produce is 12,000, and then of course the minimum point at which you will decide what not you're going to produce um, is that 8,500. That's the point at which you will decide, and then less than that you will continue to produce. Okay. Let's get into this concept called multiple order opportunities. And what we mean by that is that we're going to place several orders. So which means that we have to have some information on what we call a reorder point. All right. So over time, as we expand the inventory per cycle, we have to now place an order. But then what is that optimum order, that point at which we should place the order? Well, that depends on a very crucial factor, which is the lead time and the demand variability during the lead time. Also, it depends on how much or the quality of service that you want to deliver, which is your likelihood of meeting the demand during the lead time. So you want to make sure that you place the order in such a way that you don't run out of stock. Okay. So the reason to consider multiple order opportunities is to balance annual inventory holding and annual fixed costs to satisfy demand occurring during the lead time and to protect against uncertainty in demand. And so we have two types of policies that we usually consider. One which we call a continuous review policy, and the other one a periodic review policy. And I'll sort of just kind of give you a sense of those two in a nutshell, what we're dealing with. With a continuous review policy, what happened is that demand could be random, it could be following a normal distribution as one example. But the idea is that you would monitor your inventory level continuously until you get to this reorder point or this inventory level, and then you trigger an order, and then you should receive it by the end of the lead time. All right, so you'd have to know your order quantity Q, which is what you will place, but then you have to have some information on the demand during the lead time, and you will compute what that is, and then place the orders. So that's really called a QR policy. R is for reorder point, Q is the amount that you order every time you place the order. Okay, and here's some information, if I guess a sample question that we're going to look at. If we have the average daily demand faced by a distributor, that demand is actually variable, so it has a standard deviation. There's a replenishment lead time that is a constant lead time. You have the carrying costs, and then you have alpha, which we call a service level. 1 minus alpha is typically the risk of a stock out, and then we're trying to figure out what's the reorder point. Well, the reorder point would be typically the average demand during the lead time plus a safety stock, and the safety stock is determined by whether or not you have variability in that demand. If there's no variability, then all you need to do is to have a reorder point that is the actual demand during that lead time. So for example, if there is an average demand of rate of 2 units per day and the lead time is 5 days, then you keep 10 units of stock. But what if that demand during the lead time is variable? Then you have to hedge for values that are larger than the average, right? So if you think of the normal distribution, there are some values that are larger than the average, and you have to hedge for that, and that's where safety stock comes in. All right, and here are the calculations for that. If you notice that the safety stock is really the service level. This Z value is associated with our service level. All right, and then we have a standard deviation of the demand during the lead time multiplied by the square root of the lead time. This gives us a safety stock level. The average demand during the lead time is really just the lead time times the demand rate. And so the reorder point is made up of two parts: the average demand during the lead time, which is this piece right here, plus the safety stock. All right, and then the order quantity Q, which we've already determined from the EOQ formula. So here we have what we call a QR policy. R is this reorder point, Q is the order quantity. All right, the service level impacts your safety stock, and for different service levels we see it from 90 to 99.9%. What you notice is that the Z value increases, so it's telling you to keep more and more safety stock if you want to increase your service level, which makes sense. Um, Now let's just look at quickly this concept of periodic review. So with a periodic review system, the difference between periodic review and continuous review is that, as it's suggested, you look at your inventory level periodically. An example could be, think of you driving a car, and that you will, rather than monitoring your gas level on a daily basis, you will check out, you will just decide that you go to the gas station once a week. You're pretty confident you may not run out. So essentially, when you go to the gas station, there's not really much of a lead time, because once you decide to place the order, it replenishes is almost immediate. But the point being is that the amount that you actually will order will be the difference between what your current inventory level is and what we call a base stock level, which is really the size of the tank. So once you fill that up, that's it. So you will notice that from week to week, the amount you actually place in your tank will vary, while the period is constant. With a continuous review model, you will actually change when you place the order, right? But the amount that you order is the same every time. All right, it's the same every time. Think of it like you have two, say, cartons of milk in your fridge, and you will go and buy a new one every time you get down to one carton. All right. Well, you buy one carton each time, so the quantity is fixed. But when you actually go to buy that carton depends on how much milk you drank and how quickly you drank the milk. In which case, some days you might find yourself going for a new carton of milk 2 days after you bought the last one, 5 days after you bought the last one, 6 days after you bought the last one. It all depends. All right. So, continuous review policy, again, I will demonstrate that in a sample problem, because it's kind of hard to just do this straight off of PowerPoint slides. So I will demonstrate those a little later. But we do have an example here that shows us how to go about computing the safety stock levels in that environment. All right. Let's talk a little bit about variable lead times. What does that do? So far I mentioned that the demand could be variable. And if the demand is variable, it's tough enough just trying to make sure that we place our orders at the right time to handle that variability. But then we could complicate things even more if we now add variability in the lead time. So your lead time is variable and your demand is variable. So when you combine that, the overall variability during the lead time becomes that much more complex, larger. So because it becomes larger, what it will have a tendency to do is to increase the need for safety stock. And here's the part that actually causes this, which is really this section right here, which represents the variability of the demand during the lead time. So here's your average inventory during the lead time plus your safety stock. And as you could see, the only way to get rid of safety stock is to get rid of these two standard deviations right here, the variability. But we can't, because they do exist in real life. What we have to try to do is to find ways to reduce them, and that would help us to cut down our safety stock levels. All right. Order quantity is still pretty much the same thing. So I've already sort of given you a sense of the periodic review policy, which is really looking at your inventory periodically at regular intervals, and then placing an order for a variable quantity of product. So an appropriate quantity is ordered after each review. Okay, so short intervals daily. You could have you could define two inventory levels, S and big S, small s and big S, and we call that an SS policy, where the small s tends to be what your reorder point level is, and capital S tends to be what we call your base stock level, which is where you're trying to get to. All right, you want to raise your inventory level to that position. So in the case of the automobile, where we're filling up with gas, the capital S turns out to be the size of the tank, essentially. All right. Now you know that if we use longer review intervals, then we have to carry more stocks, more safety stock, because there's a pretty good chance you could run out. So it may make sense to always order after an inventory level review. Determine a target inventory level, the base stock level. During each review, the inventory position is reviewed, order enough to raise it to that base stock level. So that's essentially what the policy or the approach actually looks like. So calculate Q and R values as if they were continuous review model. Set smallest to R your reorder point. So that is one of the ways to think about the safety stock level. Use the same safety stock as the amount that you would use in the reorder point, but then take the same reorder point and the order quantity Q and make that your base stock level. So that's how you could actually take a periodic review, a continuous review model and transform it into a periodic review model. Once you calculate Q and R, then R becomes your small s and Q plus R becomes your large S. All right? And what would happen in this case is that the review period would be the length of a cycle, which is Q over D. That's the length of a review period in this case. So this slide is just basically reiterating what I've already just mentioned to you. Here's how we would calculate the average demand during the lead time, and with that information we could compute we certainly can compute the safety stock level, and with that safety stock level and the average demand during the lead time, we could establish the SS policy. All right. And here we are given an example where we have the average demand, the safety stock, the base safety stock level, average inventory level. Again, I think it would be easier to actually do this example over to demonstrate it rather than trying to figure it out off of this slide. Okay. Let's talk briefly about this concept of service level optimization, which is essentially recognizing that service levels have cost implications. So the higher the service level, the greater the cost. So the optimal inventory policy assumes a specific service level target. What is the appropriate level of service that you actually want? And so it could be set by a customer who say, listen, I would like to make sure that we don't run out of stock more than 3% of the time. And so, say Walmart could be saying that to its distributors, and then they would have to make sure the stock inventory in such a way that Walmart does not run out of stock more than 2 or 3% of the time. All right. So retailers may require the supplier to maintain a specific service level, and supplier will use the target to manage its own inventory, and the facility may have flexibility to choose the appropriate level of service. Sometimes that happens, not always. All right. And this just shows you what happens as you want to increase your service level. If you look, as you try to increase it, the inventory levels that you have to carry, and that's just common sense, has to be higher. All right. So what are some trade-offs that happens as a result of that? So you need to be aware of those. Is that if everything stays the same, then the higher service levels will require higher levels of inventory. For the same inventory level, okay, if you keep the same level of inventory, if you increase the lead time, then you will also lower your service level. And that makes sense because you're keeping same inventory level, but you want it to last a longer period, and so you're increasing the risk of a stock out. The lower the inventory level, the higher the impact of a unit of inventory on service level, and hence on expected profit. So what they're saying essentially is that if you keep inventory levels low, then the relative contribution of each of these inventory items to profit is a lot higher. That sort of concept. All right. In terms of a retail strategy and how we incorporate service levels into that, if you have a target service level that is across all your products in the store, or in the retail outlet, you need to identify a service level that will sort of maximize your overall expected profit across all of these items. All right. So here's some basic rules to keep in mind. Everything else being equal, service level will be higher. You will set the service levels higher for products with higher profit margins. That makes sense. Why would you want to run out of a product with a low profit, with a high profit margin? You would definitely want to make sure you have those in stock. All right. The service level will be higher for those with high volumes. In other words, high velocity. Low variability, the product variability is low, then you really don't need to have high service levels in this case. So low variability, it's fairly easy to establish the service level, all right? And then of course, if you have shorter lead times, in that case, if the lead time is short, you're able to replenish much more quickly. The service levels can be a whole lot higher, all right? And this just shows some sort of relationship between optimizing your service levels and your forecast errors. Excuse, and just shows you here what kind of service levels that we want to offer depending on the likelihood or the amount of variability associated with the various forecasts. All right. So we will end that section right here on multiple order opportunities, and then we'll sort of finalize this chapter with a segment on risk pooling.